A boy pushes a toy cart along a level road and then lets it go. As the cart is slowing down, the biggest energy change is from... Okay, when the boy lets go of the toy cart, it is moving, so it must have kinetic energy. And the reason for it to slow down is because of friction. And friction between the toy cart and the ground produces heat. So the energy change should be from kinetic energy to heat energy, B. At a height of 20 meters above the ground, an object of mass 4 kg is released from rest. So let us represent it with a diagram. So at the beginning, it has got gravitational potential energy is equal to mgh. That will be 4 times 10 times 20. We have 800 joules of gravitational potential energy. So as it falls downwards, just before it touches the ground, the gravitational potential energy will be converted to kinetic energy, which can be calculated by the formula half mv squared. That will be half times 4 times 20 squared. And we also get 800 joules of energy. And as the object continues to fall until it strikes the ground, we are given the information that the object does not rebound. So if it does not rebound, right, all the kinetic energy must have been converted to heat and sound energy on impact. So that will be 800 joules. How is heat transferred through the base of a metal saucepan? So we need to understand that metal is a good conductor of heat. So the process by which the heat is being transferred throughout the base of a metal saucepan will be by conduction only. A piece of wire has an electrical resistance of 2 ohm in melting ice of 0 degrees Celsius and 2.5 ohms in boiling water of 100 degrees Celsius. So in this case, we can say that as the temperature changes from 0 to 100, the resistance changes from 2.2 ohm to 2.5 ohms. So an increase in 100 degrees Celsius of the water will bring about an increase in 0.5 ohms in the resistance. So now we want to find out what is the resistance at 20 degrees Celsius. So if let's say the temperature increases from 0 degrees Celsius to 20 degrees Celsius, there will be a change in 20 degrees Celsius. What is the change that it will cause to the resistance? It will be 20 divided by 100 times 0.5 ohm. We will get 0.1 ohm. So this is the increase in the resistance. So what is the overall resistance at 20 degrees Celsius? We have to add in the original resistance of 2 ohm. So that will be 2 ohm plus 0.1 ohm. We will get 2.1 ohm. Answer A. In an experiment, 1700 joules of thermal energy is used to heat 8 grams of ice at 0 degrees Celsius. So we want to find out how much ice remains after heating. So first of all, we have to find out the mass of ice that has melted. We can use the formula Q is equal to mass times specific latent heat of fusion. So the mass of ice that is melted will be equal to the energy that is supplied divided by specific latent heat of fusion. Okay, so this will be 1700 divided by 340 here. We get 5 grams. So you know that 5 grams of ice has melted. So what is the amount of ice that is remaining? It will be 8 minus 5. We have 3 grams of ice remaining. Answer B.